show you an example here for sine A. Sine is what sides on the triangle? What's the ratio for sine? Opposite over hypotenuse. So the hypotenuse, the 13 is always going to be the hypotenuse, period. But the opposite and adjacent side vary depending on what angle. So this one we're looking at angle A, which means which side is opposite? The 5. So this is just 5 over 13, and you can leave it like that, or you can divide it out and make a decimal if you want to. But that's just fine, just like that. That would be what, 0.3 something.
0.3846.
Yeah. So that would be good if you did that. Otherwise, if you just left it as a fraction, that is just fine. 5 over 13. So for secant B, secant is hypotenuse over adjacent. So hypotenuse is 13. If we're looking at angle B, the adjacent leg is 5. So 13 over 5. You could leave it like that, or you could change that into 2.6 if you wanted to. So I'm going to pause again and let you guys finish. So cosecant is what sides? Hypotenuse over opposite. So of course the hypotenuse is 13. If we're looking at angle B, the opposite would be 12. So 1.0833 if you wanted to divide it out, or 13 over 12 is fine. Tangent of A. Tangent is opposite over adjacent. So according, if it's angle A, the opposite side is 5, adjacent 12. Cosine of B. Cosine is adjacent over hypotenuse. Notice how I'm always writing down the little formula and then plugging the numbers in. That saves a lot of mistakes. It's something to get used to. So cosine of B, of course the hypotenuse is still 13. That'll go on bottom. The adjacent side is, for B, 5 is adjacent. And finally, cotangent of A. Cotangent is adjacent over opposite. Good. Adjacent side for A would be 12. Opposite would be 5. So the thing to remember is the hypotenuse, of course, is locked in no matter what. But that opposite and adjacent, you got to pay attention to which angle we're looking at. And it is okay just to leave them as fractions like that. So what if I were to tell you that sine of angle A equals 0.932, cosine of angle B equals 0.4143, and tangent of angle D equals 2.837. Can I find angle A, B, and D? Another notation that's sometimes used for this that might be used in your packet, rather than saying sine of A equals that, they might say find the arc sine of 0.932. It means exactly the same thing.
You said that arc sine is an old notation?
That's an old notation, yes. Now they would most likely do, like, instead of arc cosine, they would probably do like an inverse cosine like this of 0.4143. Again, that means the same thing.
Arc sine and inverse.
Yeah. Yep. Arc sine, arc cosine, arc tangent, or inverse sine, inverse cosine, inverse tangent all mean pretty much the same thing. I just use it like this because it's an equation. Cosine of B equals this, so you solve by doing an inverse cosine. But anyway, find A, B, and D there quickly. We'll give you a couple minutes. So these are basically just a calculator exercise here. To find if sine A equals 0.932, to find A, it's going to be secant sine 0.932. Remember, use the second sign to get the inverse sign. Comes up to 68.75 degrees. You were just typing in sine 0.932, so you're getting point something. Okay. Cosine of B, then you're going to do the same thing. To find B, it's going to be second cosine or inverse cosine. 0.4143. 65.52 degrees. And for tangent of D, it's going to be inverse tangent, second tangent, 2.837. It's always good form to close those parentheses. Some of your calculators don't require it when it's just a single number going in there. But as we saw with the secants and cosecants and stuff, sometimes we're putting in a reciprocal key or whatever in there, and it makes a difference whether it's inside the parentheses or outside the parentheses. So we have to be careful with that. So 70.58. Now, without using your calculators, can you tell me which one of those is going to be bigger? Why not?
Because they're complementary.
Ah. Yeah, remember, cosine of 20 means sine of the complement. What's the complement of 20? 70. So cosine of 20 literally means sine of 70 degrees. So those better be the same. Which one's bigger? Okay, very good. You said, a couple of you said cosine. Remember, we're looking at the unit circle here. Pretend that line straight across there. And if I draw in my terminal side of my angle here at 10 degrees, and we know it's down in here somewhere because 45 degrees is halfway up. If we're below 45 degrees, remember the sine is this thing here is going to be pretty small. The cosine, which is this distance here, is going to be close to 1. It's going to be relatively large. At 45 degrees, what happens to those two? Well, if you try sine of 45 and cosine of 45, they're the same. That's where sine and cosine of the same. Well, also because 45 is its own complement. So they have to be the same there. At 45 degrees is where sine and cosine are equal. Less than 45 degrees, the cosine is larger. Greater than 45 degrees, the sine is larger. With that knowledge then, which one of these would have to be bigger? What's that? Careful. Remember, sine of 72 is going to be equivalent to the cosine of 18. Right? The complement of 72 is 18. Cosine gets bigger or smaller as the angle gets larger, as long as we're staying between 0 and 90. As the angle gets larger, the cosine gets smaller. The small angles have a large cosine. Remember, close to 0 degrees, cosine is 1. So, larger angle, smaller cosine. So therefore, cosine of 12 is going to be bigger than the sine of 72. Which one of these is going to be bigger? Careful. The cosine gets smaller as the angle gets bigger, but the sine, the sine, of course, is this dimension here. As the angle gets bigger, the sine gets larger. At 90 degrees, the sine equals 1. So the sine and cosine kind of do the opposite. At 0 degrees, the cosine of 0 degrees is 1. The sine of 0 degrees is 0. But at 90 degrees, the sine of 90 degrees is 1. The cosine of 90 degrees is 0. When we're doing stuff, a lot of times it's very, very helpful to keep this in mind. If we need to compare two angles or the sine or the cosine of two angles, rather than pulling out the calculator and punching in numbers, oftentimes we just look at them and figure out which one has to be larger. Okay, well with that, I'm going to pause this, and it is time. So just a little bit of review then. We didn't have it on this quiz much other than just filling it out. But if we were working with the calculator then, if we didn't have the triangle in front of us, how do we find the secant of 73 degrees? Now remember, we don't have a secant button on the calculator. So for secant, what button do we use? Cosine. So you're going to use cosine of 73 degrees. Does the reciprocal key go inside or outside of the parentheses? Outside. Yes, sir.
Why? Why didn't somebody just put the 3 letters?
Because apparently the 3 extra buttons on the calculator would have cost an extra 75 cents or so, and they didn't want to overtax you with that.
So there's absolutely no.
There's no reason why.
Technically, they're just
No.
somebody fell down and hit their head.
Somebody just decided those functions weren't important enough to put on there. And realistically, they're not. I mean, we're going to go through them a little bit, make sure you know how to calculate them. Once in 10 minutes, when we start actually finding pieces of a triangle, we'll never hear of secant, cosecant, cotangent again. It's all sine, cosine, tangent. But the only reason those are the functions we use are because those are the functions that appear in the calculator.
All right.
But you can get away without the rest of these. So to end up with the secant of 73 degrees is cosine of 73, x negative 1. Perfect, 3.4203. How about cosecant of 17 degrees? What trig function are we going to use for cosecant? It's going to be sine of 17. Again, the x negative 1 goes outside the parentheses. We get
3.420.
3.4203. Perfect. 73 and 17 are complements, so secant and cosecant of one should be the same as the other. So then, how about cotangent of 45 degrees? What function are we going to use? Tangent of 45. Again, we close the parentheses. X negative 1 outside should give us 1. Perfect. What if we're doing an inverse? Yes, sir.
So whenever we say cosine, secant, or cotangent, it's closing parentheses with the x negative 1 on the outside.
If we're given the angle and we're looking for the function,
Okay.
the x negative 1 is outside the parentheses. Now we're going to do it the other way, where we're given the value of the function and we're looking for the angle.
That goes on the inside.
Now the x negative 1 will go on the inside. So if I'm told that the secant of angle A equals 2.74, so now it's going to be inverse cosine, so cosine negative 1 or second cosine, 2.74, and the x negative 1 goes on the inside of the parentheses. So second cosine, 2.74, x negative 1, then close the parentheses. 68.59. Everybody get that to work?
Yeah. I guess what I'm getting confused with is the cosine or the negative.
Yep.
The negative cosine, one. I mean, that's
The cosine negative 1 or inverse cosine is what that is. That's when you are looking for the angle. That's the big thing. Anytime we're looking for the angle, we're going to be using that inverse, or the second sine, second cosine, second tangent.
okay. So trying to find the angle is always going to be.
It's when we have the angle and we're looking for the function, you just use the sine, cosine, or tangent. When you have the angle, you use the sine, cosine, or tangent. When you're looking for the angle, use the inverse. So for example, if we have that the cosecant of angle B equals 1.943,
If we have the angle, we use
the function. So if you have the angle, you use the function.
function.
If you're looking for the angle, you use the second, or the inverse. See here, we're looking for the angle. We don't have B. We're trying to find B, which is the angle. So we're going to have to use the inverse, or the second. So this is going to be second what? Sine. So it'd be sine inverse 1.943. And when we're using the inverse, of course, that's the x negative 1 goes inside if we need it. That comes out to be what? 30.98 degrees. Yes, sir.
So we're looking at the examples before, secant of 73 degrees, we have the degree of the angle, so the x minus 1 will on the other side of things.
Yeah, so here, we have the angle, 73 degrees.
Right.
So two things happen. One, we're using just the regular trig function, just the cosine.
Just about.
And the x negative 1 goes outside the parentheses.
Now, the
That's always true. We have the angle, we use the regular sign, and the x negative 1 goes outside the parentheses. We have the angle, we use the regular tangent.
One is
Just the reciprocal, is all it's saying.
okay.
What that is saying is this isn't the tangent of 45 degrees, it's 1 divided by the tangent of 45 degrees.
X negative 1 on the side.
Here, we're looking for the angle, so there's two things that happen there. We use the inverse function, or the second button before we hit the function, and the x negative 1 has to go inside the parentheses. Now for sine, cosine, and tangent, we don't need the x negative 1 at all. Okay. So the secant, cosecant, and cotangent are the ones that we have to mess around with that reciprocal key. At this point, except for on a test or a quiz at some point, and actually you will have a quiz on these on Wednesday where you'll have to be able to use your calculator to find these functions and their inverses. Yeah, I know, it's fun stuff. For practical use, sine, cosine, and tangent are what we're going to use. So I want to focus on those for a second. So I want you to find the cosine of 32 degrees. It'll be the sine of 49 degrees and the tangent of 13 degrees. So find each of those. We're going to go over them in just a second. So these are just a quick button push. Cosine of 32, you just hit cosine 32. Good form is to close your parentheses. 0.8480. Sine of 49, again, just sine 49 and close that parentheses just to be safe. 0.7547. And tangent of 13. Tangent 13, close it up. 0.2309. Questions? Yes, sir.
How can we use the x negative 1 button?
Because these are all cosine, sine, and tangent. Those are the actual functions on your calculator.
That's
The only time you use the x negative 1 is with secant, cosecant, or cotangent.
okay. When we have the angle.
Yeah. Well, anytime you're doing secant, cosecant, and cotangent, you're going to need the x negative 1 at some point in the process.
Either on the inside or the outside.
On the inside or the outside, yeah. If you have the angle, it's on the outside. If you don't have the angle, it's on the inside.
Yeah, I don't think I know.
One of my friends posted on my Facebook this weekend, I like teaching math because it makes people cry. It's like, wow. It kind of makes me feel a little bad.
No, don't. Water. Got to know find how old that works. Is the leading zero pertinent?
No, you don't have to punch that in your calculator. I always put it in there because in the and I teach a couple of classes for nursing and medical fields.
Mm-hmm.
In the medical fields, they put that in there because there were a lot of mistakes made. If it's 0.8 milligrams, a lot of times they'd miss that decimal point, so having the 0 in front makes it very clear that that's 0.8. So I'm used to putting that 0 up front so that that's distinguished is all. But yeah, on the calculator, like when I do the sine, of course, here, I forgot to put a cosine on. Now in this case, do we have the angle? No, we don't. In all four of these problems, we are looking for the angle, which means we have to do what on the calculator? Yeah, we're not using sine, cosine, or tangent. We're using inverse, which is the second key. So for the first one here, sine of A equals 0.9374. To find A, I have to do second sine.
X negative 1 on the outside?
Nope, there's no x negative 1. The x negative 1, remember, is only secant, cosecant, and cotangent. Sine, cosine, and tangent are the buttons on your calculator. So the x negative 1, we don't need. So this is just going to be second sine, 0.9374. That's almost 1, which means this angle better be close to 90 degrees, right? That's like 69.62, so that's pretty close. That's degrees. So sine of B equals 0.3947. How are we going to do that? Second sine, because again, we're looking for the angle, so we have to use the inverse or the second function. 0.3947. 23.25 degrees. Anybody need me to give you a second to do the last two? Okay. Tangent of E equals 0.1342. So we're going to do, since we're looking for the angle again, it's second tangent. 0.1342. 7.64 degrees. And finally, cosine D, it's going to be second cosine, 0.4444. 63.62 degrees. Okay, so we've spent a few days doing calculator work on these functions. Now, the meaning behind all of it. Why have we done it all? Well, it comes down to finding missing pieces on figures and drawings and triangles. If you're given a triangle that looks like this, and you're told that the hypotenuse here is 15 millimeters, and of course you're given that this is a right angle. At this point we have to be given a right angle or none of this stuff makes any sense. Pretend that's a straight line. And you're told that this is 31 degrees. Now, angles A, B, and C, remember C is always the right angle. The opposites, the sides are always labeled for their opposite angle. So this side would be side little a. Yeah. This would be little c, and this would be little b. Now of course, I can find this angle here really quickly because I know they have to add up to 180. In fact, since I know this is 90 degrees here, I know those two have to add up to 90. So this angle is going to be 59 degrees. Sides A and B take a little more work. First thing, I always warn, go back to information you're given. The 59 was something we calculated. Yeah, it's exact, but there's that small chance we screwed up. I see it done all the time. Instead of 90, people subtract from 100 or something silly like that. So go to what you're given. You know that is correct. You know that your information is correct. You didn't make any mistakes on it. So the 31 degrees is what we're going to use. If I want to find side A, well, information I have or what I know angle A is 31 degrees, and I know side little c is 15 millimeters. So according to angle A, what side is C? The hypotenuse. So what I've done is I've picked out the information I know. I know an angle and I know the hypotenuse. The next thing I want to figure out is what is it I'm really trying to find? Well, I just said I want to find side A, which is according to the angle I'm using, it is the opposite side. So what I'm working with here is opposite and hypotenuse. Looking at your list, what trig function is opposite hypotenuse? Sine. So I'm going to write it out. Sine of an angle is the opposite over the hypotenuse. So now in this formula, sine, of course, is a function. Do I know the angle? Yeah, what is it? 31 degrees. I'm putting 31 degrees in there. Do I know the opposite side? No, that's what I'm looking for. That's my side A. So I'm going to put A there. Do I know the hypotenuse? Yes, I put in 15. See how easy that is to plug in the numbers if we have the formula sitting in front of us. Again, I can't stress it enough. Take the 3 seconds to write out the darn formula. Now to solve this, the easiest way for me to solve these is to turn it into a proportion. And it's cross, multiply, and divide. So I'm just going to put this over 1 to make it a complete proportion. And then to find A, I'm going to cross multiply. Sine of 31 times 15 divided by 1. Now in this case, you probably could have just solved the equation, multiplied by 15 to get A by itself. but in a second you're going to see why that's important. So sine of 31, this is why we practice closing the parentheses. We have to make sure we do that here. Times 15 divided by 1. If you're lazy, you don't have to divide by 1. Now, usually we'll go to 3 or 4 decimal places on the sides here. Let's go to 3. We'll go 7.726, it looks like. So A up here is 7.726 millimeters. Everybody get that to work? No? I'll give you a second. So sine of 31, make sure you close the parentheses.
31.
Close parentheses. Then divide by 1. Okay. So now if we ask to find side B, we still know the same information. We know that side C is 15. We still know that angle A is 31 degrees. We're asked to find side B, which is the adjacent leg. And of course, the C is the hypotenuse. So we have the adjacent and the hypotenuse, which is what trig function? Cosine. And we know that the cosine of an angle is adjacent over hypotenuse. So again, I stress it, write out the formula. Filling in our information. Do we know the angle? Yes, we do, 31 degrees. Do we know the adjacent side? No, that's what we're looking for. That is side B. Do we know the hypotenuse? Yes, that is our 15. And once again, I make it a proportion. I put this over 1, and we cross multiply and divide. So this will be cosine of 31 now. Again, make sure we close the parentheses. Times 15 divided by 1. Now we get 12.857. 12.858. $12.86 would have been probably close enough, yeah. Now, there was another way we could have found B if we wanted to here. Because this is a triangle, well, I'm going to throw this out as a way to double check. Once you have these missing pieces, you know that since this is a right triangle. Okay? So you can go back and double check here. We have 7.726. Now, is this going to be exact? No, it's not. Because these two are both rounded off. Now, what I'm going to do is I'm going to do the 15 squared first, 225. The only reason I did that first is because there's no decimals there. It's a nice, neat little thing to round, or to square. And now I'm just going to use the calculator on this other part here. 7.726 squared plus 12.858 squared. I want something really close to 225. Now, both of these got rounded up, so I'm probably going to be a little bit more than that. And there it is, 225.02. I'm probably close enough. Now, I said that on those we didn't really need the proportion, but there are some that we will. That's why I do it, because everybody gets used to your triangles always looking like this, and you get stuck in that. That's why I make sure I make them different directions. So here, again, we'll label them angles A, B, and C. So this is little a, little b, little c. Find sides B and C. Of course, we know we can find this angle is going to be 19 degrees because they have to add up to 180. But we're going to use the 71 degrees because we know that's right. It was given to us. There was no way we could have screwed that up. Somebody else might have screwed it up, but we're only responsible for the information that's given to us. So now to find side C, let's say. Side C is what side of this triangle? It is the hypotenuse. we have or given side A, which is 0.4 inches, and that is the adjacent side. And we're also given angle B, which is 71 degrees. So we are given the adjacent side. We are looking for the hypotenuse. Those are what we need. We need to have two sides all the time. Sometimes we'll be given two sides, but most often we're given one side and we're asked to find the other. So adjacent hypotenuse make what trig function? Cosine. So again, cosine of an angle is adjacent over hypotenuse. Plugging in what we know. Do we know the angle? Yes, 71 degrees. Do we know the adjacent side? 0.4. Do we know the hypotenuse? No, that is side C. That is what we're looking for. Now, here's why this is the type of problem where doing that proportion is important. Because C is on the bottom of a fraction, it's really kind of difficult to solve an equation for that. But if I make it a proportion, it's really simple. I'm going to cross multiply 1 times 0.4. So 1 times 0.4, of course, is going to be 0.4. And then I'm going to divide by the cosine of 71. Gives me 1.229. So 1 times 0.4, and then divided by the cosine of 71 degrees. .229. There you go. You'll live. Now in this case, I'm asking you to find angle A. Now angle A is not a side, so we don't need to figure out what side it is. In this case, when we're looking to find an angle, the process changes just ever so slightly. We have to be given two sides, and in this case we're given, this is side A, this will be side B, this will be side C. We're given side little a, which is 14 millimeters, and which side of the triangle is that? Which leg? So if this is A, that would be the opposite side. If we were looking at B, it would be the adjacent side, but we're wanting to find angle A. We're also given side B is 21 millimeters. It is the adjacent leg. We have adjacent and opposite, which is, of course, say it would be cotangent, but it's also tangent. Why don't we use the cotangent? Because it's not a button on our calculator. It's the only reason why. Tangent's on our calculator, so we want to use the opposite over adjacent is the tangent. Now in this case, do we know the angle? No. It's angle A, so I'm going to put A in there because that's the angle we're looking for. Do we know the opposite side? Well, we better. We already don't know the angle, and we can only have one unknown. The opposite side is the 14. The adjacent? 21. Now here, it's different. We are not going to turn this into a proportion. What's different about this one? Yeah, all the other ones we've been looking at, we were looking for one of the sides. This time we are looking for an angle. So to find the angle, we're going to do an inverse tangent. So it's secant tangent. And then inside there, it's going to be 14 divided by 21 and close the parentheses. So secant tangent, 14 divided by 21, close those parentheses, and we get
33.69 degrees.
Perfect, 33.69 degrees. And that is all the time we have for today, so your homework is going to be in that packet I just handed out. Page 351 through 354, finding the missing pieces of those triangles.